All right, so the last thing I want to cover of this part of expanding and condensing logs would be how to expand it. So if I see this log function right here, I see that it's already condensed pretty far. So I'm going to take a look at this, and I'm going to see that I have log base 2 and then x to the 7th divided by y3. So right away, I see this division, and I know that I'm going to actually be subtracting my logs because of that division right there. And I want to make sure that whenever I am expanding anything, my log will always stay the same. So if my initial thing has log base 2, all of the separate parts of my expanded function are going to be log base 2. So taking a look at this, I can start off with log base 2 and then what is being divided. So since x to the 7th is the numerator, I know that that will be my first, and that comes before the y cubed. So I have log base 2, x to the 7th. Now, because of the rule of division and subtraction, in order to divide, I'm going to be subtracting this next log. So again, it'll be log base 2, and then whatever is on the bottom. So we are dividing by y cubed. That means y cubed would follow x to the 7th. And it's subtraction again because you are dividing the 2. So this looks already pretty expanded, but we can go even further. So I'm going to take a look at each one, this log base 2. And here's what we learned. So if this is to the power of 7, I know that this can actually become the coefficient for this log. So the 7 comes first, log base 2, and just x. Then here, keeping the subtraction, I see that y is to the third. So whatever you're taking the log of, if that is raised to a certain power, that power can be eliminated from what you're taking the log of and brought to the front as the coefficient. So since I'm taking y to the third power, 3 would be my coefficient, making sure to keep my log base 2 and keeping the log all there and y. So that's just an example of how to expand, and there will be some more practice on that.